number looks like might still be going up a little bit. But as you all are joining us, welcome. Thank you so much for coming tonight. Welcome to the summer and welcome to our May Science on Tap event, Building Climate Resilient Communities with Nature. For those of you who don't know me, my name is Sierra and I am a member of the Science Policy Society at Penn State and also a PhD student in geosciences. Science Policy Society is a student organization and we work at the intersection between science and policy. We focus on education, legislator engagement, and community outreach. And Science on Tap is one of our main outreach initiatives. And these are really fun events that provide us an opportunity to learn about a lot of different really interesting scientific topics from really cool scientists. And the good thing about the Zoom format is that it allows us to expand to include scientists that are beyond State College, beyond Pennsylvania. So we're really excited to have Dr. Sydney Chamberlin here today. And I will turn it over to Hannah to introduce her.
All right, hi everyone. We're so excited to have you all here today. We're excited to have Dr. Chamberlin here with us today. She received her PhD in physics from the University of Wisconsin-Milwaukee, where she contributed to the first detections of gravitational waves. She then served as a postdoctoral scholar here at Penn State before becoming a science fellow of the California Council on Science and Technology, where she worked with the Senate Committee on Natural Resources and Water. Dr. Chamberlin is currently a climate policy associate at the Nature Conservancy, where she combines science, conservation, and policy to advocate for nature-based climate strategies in California. And so she'll be talking to us a little bit about that today. But as always, before we get started, we'd like to get everyone feeling the casual atmosphere with some trivia questions. So I'll get those loaded up. Okay. You can see that, Sierra? Okay, great. So our first question is, which of the following is not supported by nature-based climate solutions? And feel free to fill in the poll here. We have A, oh wait, did it load the wrong one? I'm seeing the ecosystem question. Oops. Well, we can move to that one. We'll go to the ecosystem.
Sorry, I don't know what happened.
Here, all right. We'll start off with this one. So which type of ecosystem is more efficient at storing carbon? Is it a forest, grassland, wetland, or tundra? And just fill in the poll with your answers. We have almost everyone answered at this point. Okay, so it looks like it's tied between forest and wetland, and that's both really great guesses. Wetland is the correct answer, but it's a close tie. So good job, everyone. All right, do you want to launch the next poll and then I'll find the slide?
Yeah, it looks like now I will go to number one. So
okay. All right. So now, which of the following is not true of nature-based climate solutions? A, they ensure access to local food. B, they safeguard communities from floods. C, they protect species habitat. Or D, they are only suitable for high-income communities. Quick voting going on. All right, well, we have 80% of the votes in, and it looks like almost everyone agrees that the only one that they are not is suitable for high-income communities. which is true. In California, more than 60% of the land suitable for nature-based climate solutions falls within disadvantaged and low-income communities. So good job. You guys got that one right. All right, Sierra, you want to do the next one? Okay. By 2050, 28 million acres of land in California can reduce greenhouse gas emissions by over 500 million metric tons. This is equivalent to reducing California-wide emissions from the transportation sector over how many years? A, 1 year, B, 3 years, C, 5 years, or D, 10 years. This is a toughie. Votes are a little slower on this one. I can understand that. All right, well, we have 83% of the votes in for, looks like 5 years is what most people selected. However, that's not correct, but it's close. It's over 3 years. So pretty close, everyone. All right, we just have a few more trivia questions left, and then we'll get started with our talk. Nature-based climate solutions can provide up to what percent of the emission reductions needed by 2030 to keep the global temperature increase under 2 degrees Celsius? Is it A, 5%, B, 12%, C, 26%, or D, 37%? All right, we're at 75% of all the votes in. Okay. So you guys are close again. Most people selected C, 26%, but it's actually D, 37%. So pretty close to the right answer. And I think we have one more.
Yes. Yep. Next one.
All right. Feel free to read the last one if you want, Sierra.
All right. Where does the US rank for countries with the highest proportion of CO2 emissions? %73, 76%. Okay, I'm gonna stop the polling now. And yes, the majority of people got it correct. The US is second.
All right, and I think that should be all of them.
Yeah, that's all.
All right. So great. So with that, we're gonna hand it over to Dr. Chamberlin, and we're excited to hear her talk today. And then we'll have time at the end for questions as usual. Feel free to write in your questions in the Q&A pod, or if you have just kind of discussion items or things to talk about, put that in the chat. But please put your questions in the Q&A pod so we can find them later. All right, all you, Dr. Chamberlin.
The only thing is when I try to share screen, I get the host disabled participant screen sharing. So I just need to get a button clicked somewhere.
All right, did that help?
I will fix that. Can you do it now?
Yes, thank you, perfect.
Awesome.
Perfect. Okay, I'll get myself combobulated here. Can you guys see my screen and hear me? I'm just gonna like continue unless anyone tells me you can't hear me, but otherwise I'll keep going. And hopefully you're seeing like the correct view of this and it's not like my presenter view. Thank you for the introduction. Those questions really fun, and I was impressed at how everybody did. There were a couple zingers in there. I mean, that one on California, I would be like shocked if, anybody knew. So well done, everyone, well done. It's great to be here this afternoon. I know it's evening for some of you. Before we get going, a couple things. So I'm calling in today from Sacramento, California. This is an area that has a rich heritage and culture. And I'd just like to start by acknowledging that I'm calling in from the traditional territory and unceded land of the Miwok people who stewarded these lands and called them home for thousands of years. And I'd like to acknowledge that you're joining today from many places near and far. And I just want to take a moment to acknowledge the traditional stewards of those lands. Now next, I'd like to tell you a bit about myself, especially because I can't see any of you, and it's such a weird and strange way to give a public talk this way. Normally I like to stand around and wave my arms around and stuff, so it's really weird like not seeing your faces. But I'm just going to start with some slides to help. So I'll start with a nod to Penn State. I'm a scientist by training. My career actually got its start in astrophysics, so I spent 6 years studying gravitational wave astronomy, which is this niche field of astrophysics in Wisconsin. And then after I finished my PhD in 2015, I went to Penn State and I worked there for 3 years before I transitioned into the policy world. And it's really exciting to see some familiar names in the Zoom participant list here. So hi to all of you, the familiar names, and also hi to all of you who I don't know. I'm excited to meet you. I'm excited to talk to you today. Thank you for being here. Just to tell you about my career, in 2018, I took a leap and I pivoted away from science into the science policy world. And as a side note, if there are grad students listening in who are interested in or like curious about the policy world, I'm super happy to talk about what that transition was like and like this huge career change. So just feel free to email me or reach out in the questions. But I did this science policy fellowship, and it was coordinated by a nonprofit called the California Council on Science and Technology. They sent me to work for a year in the California State Legislature. And in that role, I analyzed legislation related to natural resources and climate change. So pretty big change from astrophysics, of course. But a lot of time thinking about how we manage our natural resources and how we're mitigating and reacting to climate change. And all of that experience led me to my current role. So now I work as a climate policy associate with the Nature Conservancy in California. And if you haven't heard of the Nature Conservancy, we're a global environmental nonprofit. Our mission is to conserve the lands and waters on which all life depends. And as you can imagine, climate change poses a huge threat to our mission. We're fundamentally a science-driven organization, but my work with the Conservancy actually focuses on policy. And specifically, it focuses on California policy related to climate change. So today, I want to share a really exciting suite of climate solutions that can not only help us to fight climate change, but also to ensure that we have thriving communities in the future. And while my expertise, especially in policy, is on California, this suite of climate solutions is something that can be implemented everywhere, all over the globe. So let's jump in. But before we jump in, it seems really funny to me to talk about solutions to a problem without talking first about the problem. So let's just start first by reminding ourselves how this climate change problem works. So I have this little gift from NASA. Our planet is continually getting light and energy from the sun. So that light hits the Earth. Some of it gets reflected back into space. Some of it's absorbed and re-radiated as heat, and gases in our atmosphere trap that heat. And we'll watch it again because it's going like way faster than I'm talking. So here's sunlight hits the Earth. Some gets reflected back into space. Some is absorbed and re-radiated as heat. And most of that heat is absorbed by greenhouse gases and radiated everywhere, warming the Earth. So these gases in our atmosphere are trapping that heat. And to remind ourselves what greenhouse gases are, these gases are typically carbon dioxide, methane, nitrous oxide, and water vapor. And you don't have to know too much about them, except for those are gases that all occur naturally. There's also something called fluorinated gases on this chart. They're listed as F gases. Those are synthetic gases. So we have all these different gases in the atmosphere, and they all have different chemical properties and different lifetimes in our atmosphere. and some of them influence global warming more than others. But we know from science how potent each one of these gases is relative to carbon dioxide. And what we do is, whenever we're talking about climate change, we just sort of convert the other gases into a carbon dioxide equivalent. And so from this point forward in this talk, I'm really just going to talk about carbon and carbon dioxide. I just want you to know that other gases play a role. And so when I say greenhouse gas, it means all these things. But in this talk, we'll just say carbon and carbon dioxide. And while we're here talking about carbon, kind of helpful to review the carbon cycle. This is something I had to review a couple of years ago when I realized I had no idea. And there's sort of something weird going on with my little animation here. So ignore some strange half letters in the middle. But carbon is an incredibly important element for life. It's the foundation of life on our planet. And our planet, along with its atmosphere, are like a closed system that collectively has a fixed amount of carbon. But where the carbon is in that system can change. So carbon atoms can travel from the atmosphere to the Earth, or they can go back from the Earth to the atmosphere. On Earth, carbon is stored by rocks and sediments, it's stored in the ocean, and it's stored in living organisms like us, in animals, and plants and trees, and soils. And at least for plants and trees, it gets there through processes like photosynthesis. In other, rocks and sediments, it can get there through the decomposition of organic matter. And these reservoirs, or sinks, we call them, of carbon that we have on the Earth can then release carbon back into the atmosphere. So if an animal dies, or if a fire burns trees or vegetation, or we burn fossil fuels, all of those things can release carbon back into the atmosphere. So the primary way that humans interact with the carbon cycle is through the burning of fossil fuels and through land use or land development. And this is a really important point that I'm going to come back to, that disturbing or developing land can release the carbon that's stored in that land. Now, over the last century or so, human activities like deforestation and the burning of fossil fuels have increased the concentration of carbon dioxide in our atmosphere. And that's resulted in extra trapped heat and higher global temperatures. So this graph shows you that. It shows you how carbon dioxide levels have increased over the past 800,000 years or so. And the current level is really scary. We have like this dashed line that's like, for millennia, carbon had never been seen above this line, and then suddenly we're way up here. Not good, right? So we're at a level that's much higher than ever before. And what does that mean? Let's talk about the impacts of a warming planet. As our planet heats up, it changes the Earth's climate systems. So the warming causes more frequent and intense weather events. That includes everything from droughts to hurricanes to heat waves and floods. It causes greater extremes in precipitation. We might have vastly more precipitation in some regions and vastly less precipitation in others. It causes sea level rise due to melting glaciers and warming oceans. And it impacts ecosystems. It changes the ranges, the migration patterns, and the seasonal activities of wildlife and other species. As our climate changes, it's not just plants and wildlife that are at risk, but our livelihoods too. And it's not just from extreme heat, it's not just from weather like hurricanes, but the things like droughts that happen impact our food supply. They impact things like the spread of disease. And in fact, events like global pandemics are more likely to happen in this climate future. So all this together is not good, right? It seems very dire. Oops, let's see. There we go. This plot, or this graph that I'm showing you, is temperature data from NASA's Goddard Institute. And on this plot, they have something called a temperature anomaly. So a temperature anomaly is just how much warmer or cooler than the long-term average something is. And if we look at this graph, and you look at the recent years on this graph, because it goes from 1880 to 2020, you can see that the data for more recent years is climbing and climbing. 19 of the last warmest years have occurred since the year 2000, with the exception of the year 1998. 2020 tied with 2016 for being the warmest on record since record keeping began in the year 1880. And the scale on the y-axis on this graph, it's not big. It's in degrees Celsius. It doesn't look like much. You're sort of saying, oh, like temperatures have gone up a degree Celsius. Doesn't sound like much. But when we're talking about these global changes, it makes a big difference. And so the question is, what do we do about this? So the short answer is we need to limit warming. And in 2015, a landmark international accord called the Paris Agreement was adopted by nearly every nation in the world. The agreement aims to substantially reduce global greenhouse gas emissions in an effort to reduce or limit the global temperature increase in this century to 2 degrees Celsius above the pre-industrial levels, while pursuing chances to limit the increase to even less. But then in 2018, the Intergovernmental Panel on Climate Change, which is a panel formed by the UN, recommended, based on the best available science at that time, that we even further limit global warming to no more than 1.5 degrees Celsius if we want to avoid the most catastrophic climate impacts. So here we're talking, even just a half a degree more, 1.5 degrees, 2 degrees, that difference is big. It could mean substantially more extreme heat, sea level rise, habitat loss, drought, and ultimately poverty for people. So it's clear that we need to reduce the warming. And how do we do that? So that's the problem. And to kind of walk us through what we can do to solve that, I want to use an analogy. So this is an analogy called the carbon bathtub. And the way this works is the following. So imagine for a minute that the atmosphere is like a bathtub. And the water in the bathtub is carbon dioxide. So carbon dioxide is pouring into this tub. And let's talk about where it's coming from. About 80% of the carbon dioxide that's pouring into this tub is from fossil fuel emissions. So, that comes from us creating electricity, it's from industry, it's from transportation, but ultimately it's from burning fossil fuels. And most of the rest of it is from things like deforestation and land use. We're developing land. Some of it's not even us. Some of it's wildfires that are burning, but it's deforestation and land use. So all that's going in and is filling this tub. But there's good news. Thanks to the carbon cycle that we discussed a couple slides back, there are actually some drains at the bottom of this tub. They don't all drain at the same rate or on the same time scales, but they let carbon dioxide flow out of the tub and back to the earth. So let's talk about the drain. Because plants and soils can sequester or store carbon, there's a drain for plants and soils. And you could imagine that maybe like every year, 30% or so of the carbon dioxide in this tub managed to come out and go into plants and soils. And then there's another drain that goes to oceans, which absorb something like a quarter of the tub's contents every year. And there's a really tiny drain that goes to sediments and rocks that takes like less than 1% of what's in the tub. It's a long process. Not a lot comes out, but it does take a little. And if we add all those numbers up, it means that every year, maybe something like a little more than half of the carbon dioxide can drain out. But that leaves almost half in the tub. And so, in other words, we're pouring carbon dioxide into this tub faster than nature can drain it out. And that's making our planet warm up. And it's a real problem because the carbon dioxide that stays in this tub can stay for a really long time. In fact, it can stay in our atmosphere for hundreds to thousands of years before it decides to drain out. So long, long time. So again, all this sounds really dire, but there's two ways that we can help ourselves. First, the very first thing to do when your bathtub is overflowing is to turn off the faucet, right? So we need to stop adding more to the tub. And what that means is dramatically reducing our greenhouse gas emissions. Because carbon dioxide can live on our atmosphere for so long, for like 1,000 years, this is critical. The sooner we stop the flow of carbon dioxide into the atmosphere, the better off we'll be. But the other thing we can try to do is to enhance the ability of the drains in the tub to remove carbon. In other words, we can increase our ability to store and sequester carbon on the earth. And by the way, these two actions together are often referred to as climate mitigation. Mitigation is a phrase because they're helping to mitigate this overflowing bathtub that is our atmosphere. So I've told you all this doom and gloom stuff, but now we're at the good part, the sort of the meaty part, which is the solutions. There is an existing suite of tools that we have available that we can use to mitigate climate change that does both of these things. It's based on known, proven technologies. We don't need new technology to keep working on it. They're easy to implement and they're relatively inexpensive. And those tools are called nature-based climate solutions. So what are nature-based climate solutions? These are land conservation, restoration, and management activities. And collectively what they do is these two things. They avoid emissions that would come from disturbing the land, and they improve the ability of our lands and the ecosystems our lands house to store carbon. So all that probably sounds a little bit abstract. And so I want us to like jump in and get a little bit more into the weeds. So we have a really diverse planet. We have a lot of different kinds of lands on this planet, but we could think about grouping them roughly into 3 different categories. We've got natural lands. These are things like forests, wetlands, grasslands, even deserts. We've got the lands that we're using to produce food and fiber through agriculture and livestock management. So, agricultural land and rangeland. And then there are the lands that we have in our urban areas. These are the lands that are most likely surrounding you outside of wherever you are right now. And in each of these lands, there are multiple ways that we can use land management, land conservation, and restoration activities to reap climate benefits. So what I'm going to do next is just kind of list a few of these activities in like a lightning fashion. And I'm not getting into the science of like how each exact activity works, because I think that would need to be its own whole science on Tap Talk. But I just want to give you a sense of, what are these actions? What compromises this suite of solutions? So let's start with the natural lands. One of the very most important things we can do is to avoid converting any land that's natural into a more intensive use. Anytime we develop land into a more intensive use or we disturb it, we risk losing the carbon that's stored there. And frankly, the other benefits that land provides, like cleaner air, water storage, or wildlife habitat. There are a lot of other solutions that involve natural lands too. So when they're healthy, wetlands are incredibly efficient at storing and sequestering carbon. I think this was one of the trivia questions. I mean, maybe everyone's mind goes to forests when you think about storing carbon, but wetlands are absolutely incredibly efficient at storing carbon. But other ecosystems can be restored for climate benefits too. So we can do things like restoring grasslands, the wooded areas along waterways and rivers. So if you've ever taken a hike on a river and there's kind of like wooded area around you, restoring that area can make a difference. And then forests are a big one here, and one that gets a lot of attention. So like wetlands, forests can store a lot of carbon, and our forests are at risk. So deforestation is a major source of greenhouse gas emissions globally. And frankly, speaking about the greenhouse gas emissions doesn't even get to the impacts that deforestation has on biodiversity. We really are facing almost twin crises right now in biodiversity and climate change. So thinking about, what we're doing with deforestation is important. Then we have wildfires. I think there's at least a couple people on this call who are from California, and I'm assuming the rest of you probably at least experienced smoke from California coming to where you are. We had a huge and horrible wildfire season last year. These fires are a big problem, and they threaten people's health and homes directly. But when the forests go up in smoke, it's not just about people's homes and health, it's also about those climate benefits going up in smoke. So we have to kind of rethink the way we do forests and restore them. The forests we have in California actually evolved with fire. It's like a naturally occurring part of this ecosystem. And what we've done is spent decades suppressing fires. So we have a lot of restoration work we can do. If we strategically thin fuels, literally by hand, like going and removing dense underbrush, and we use prescribed burns, we can improve the health of our forests and reduce the risk of catastrophic or severe wildfire. And in turn, that reduces the risk of emissions quite a bit. Then we have a whole suite of things we can do on our ag lands and rangelands. So let me list a couple of these. You may or may not have heard of cover crops. You can think of cover crops as plants that are planted to just cover the soil instead of for the purpose of being harvested. So you have your normal crop that you harvest, but then in the middle season, maybe you plant something that just covers the soil. And what that does is help to manage soil erosion, improve soil fertility, soil quality, water in the soil, and more. So that's one solution. Another ag solution is improving the use of nitrogen fertilizer. So Anytime we apply synthetic fertilizers to croplands, excess nitrogen gas either gets released to the atmosphere or carried away by water. So by ensuring that we apply the right amount of nitrogen fertilizer to crops, like the minimum amount we need, that can help. And then finally with ag, there's solutions that pair trees and hedges with agriculture. So for example, we could use trees or hedges as windbreaks and shelter for crops. When we put trees on farmlands, they help reduce and prevent erosion. They help enhance diversity in crops. They maintain moisture levels in the soil. And they do all of that while they reduce emissions from disturbance and degradation. So, this is just, by the way, a handful of possible things we can do on ag lands. I'm giving a few examples and not the whole suite here. Then we come to urban lands. So this is my third category. And it's really fun to think about mitigating climate change in urban areas. So one approach here is to increase tree canopy by planting trees. And we can add other kinds of vegetation and greenery to urban spaces too. And there's something worth noting about these activities. You might have thought to yourself as you're listening along something like, planting more trees and adding greenery can also make urban areas look nicer. Or if you're like me and you live in a city, you might be like, well, adding greenery to urban spaces must be good for those raccoons that are always in my garbage. And this touches on something that I have completely and totally left out so far. So let's get to that. This is something really important. I spent all this time leading up to nature-based solutions and how they help us mitigate climate change. But the reality is they do more than that. So our lands and the ecosystems they house, they don't just provide climate benefits. They also give us food and fiber. They provide cleaner air and water. They provide homes for wildlife and plant species. They give us recreational space, open space. They allow species to migrate and connect to different areas when their homes are threatened. And then finally, they can even reduce risks from disasters like floods. So when our ecosystems are healthy, they're more resilient to change. When we restore, conserve, and maintain the health of our lands, we ensure that they can continue to provide these services. And so nature-based solutions are cool, not just because we use them to mitigate climate change, but also because they carry with them this extraordinary suite or array of complementary benefits for people in nature. And if we just look at the last couple of little icons on this slide, so I have flood risk reduction and habitat resilience, that touches on something else. If you called in from California, you definitely know this, but I think everyone else probably realizes it too. We're at a point where we're already experiencing the impacts of climate change. We can't avoid it. Even if we accelerate our action in the US and across the globe, it's unlikely at this point we're going to avoid future impacts. Lessen them? Hopefully, yes. But avoid them, no. So as we plan our communities for the future, we have to plan with climate in mind. And even more holistically than that, we need to think about the role that lands and nature play in supporting thriving communities. So let me just share a couple of examples here. In urban areas, there's often increasing pressure in many places between the demand for growth and increased housing on one hand, and the need to conserve land and prevent sprawl on the other hand. And science can help us find a course of action that meets the needs of communities while preserving the lands that are, or preserving the services that our lands provide. So in this example, in 2019, the Nature Conservancy in California, we partnered with the California Department of Conservation to explore this idea. And we looked at a county in California. It's called Merced County, and it's this green blob on this map here. And in looking at this county, we thought, well, how do we mitigate this, this contentious thing where, there's this development pressure, but we want to also conserve land. What do we do? So we developed something together called a decision support tool. And what the decision support tool is, it literally takes science and lets us look at different future climate scenarios with different land uses. So it produces something that kind of looks like this little graph on this paper. So on the left-hand side of this, we have what we call like the reference scenario. That's like business as usual. Let's just continue exactly what we're doing now. And then we have this scenario called max infill. I don't want you to be intimidated by the name. Infill means developing or prioritizing the development of vacant or underutilized lots in cities. So infill is kind of like, let me develop that empty space between two buildings somewhere. And then there's scenarios that really emphasize on the far right-hand side of this image, hey, let's incorporate natural and working lands conservation fundamentally into our planning strategy. So all the different pictures on this, the 4 panels here are representing like 4 different land use scenarios. Like, are we going to just keep doing what we're doing now? Are we going to develop mostly on empty lots already in the city? What if we kind of try to stay compact? What if we really fold conservation into what we're doing? And this decision support tool really lets communities see at a quantitative scale how one strategy compares to another. So with tools like this, communities actually have a quantitative way to do decision making with climate mitigation benefits and co-benefits from scenarios. The numbers here on the top tell you something about how much greenhouse gas emissions come from each scenario. And so you can look at this and say, well, oh, there's a clear solution quantitatively, at least in terms of what's going to minimize our carbon footprint. But ultimately, the community's got other priorities too. So this is a neat example of how, at least holistically thinking about land use and nature can impact what a community is doing. Let me share another example, though. This one is really cool. So this one involves coral reefs in Yucatan, Mexico. In 2005, Mexico's Caribbean coast was struck by 2 hurricanes. They caused $8 billion in damages. They closed hotels and other businesses in Cancun so long that caused further economic impact. But there were some hotels and beaches that suffered less damage than others. And after folks went and analyzed to figure out, well, why were these ones less damaged than the others, the analysis revealed that the less damaged stretches were protected by the Mesoamerican reef. So this is a coral reef. And this kind of makes sense based on what we've discussed in this talk, right? That when the natural systems around us are healthy, they're able to protect us. And I have a cool video here that for some reason always plays really loud. I'm going to try to turn the sound off right away when it starts. Scientific analysis that followed all this showed that a healthy coral reef can reduce up to 97% of a wave's energy before it hits the shore. So let me show you this video. I'll try to turn the sound. Oh, wait, it went too far. How do I get this to play? There we go. There we go. So here we got like a wave, and it's hitting these mangroves in this demonstration. We got this like vegetation here, and you can see that this vegetation just totally absorbs all of that, right? So, that video right there underscores the ability of systems like coral reefs, beaches, and wetlands to provide a first line of defense against storms. Of course, coral reefs themselves can be damaged in storms, and so this event precipitated the first ever of its kind insurance policy for a coral reef. Literally the first time, as far as I know, that anyone has ever designed an insurance policy for a natural resource. It was pioneered by the government in Quintana Roo, the Nature Conservancy, and some other stakeholders. And if folks are interested, we can talk a little bit more about insurance applications to all this after. But the idea again here is that when we protect nature, nature can help to protect us. And so right now we're looking at similar strategies to this Mexico example to fund the maintenance and restoration of wetlands in the San Francisco Bay. Pretty cool stuff. So the last example I have here, this is a photo of a site called Hester Marsh. It's a tidal marsh located in the Elkhorn Slough of the Monterey Bay in California. So I don't know if any of you have ever been to like the Monterey Bay Aquarium, but this isn't too far from there. And this is one of California's largest estuaries and the largest salt marsh south of the San Francisco Bay. It's vital habitat for migratory birds, for fish, for marine mammals, and more. And the Elkhorn Slough is surrounded by development and highly productive agricultural land. So what's happening on this site is that there's restoration work, wetland restoration that's restoring about 120 acres of marsh. And what that will do is to increase carbon sequestration. So this work is literally mitigating climate change. But it is also protecting adjacent communities against sea level rise and flooding and providing improved surface water quality. I had to add a sea otter, improved sea otter habitat. By the way, they have a sea otter cam. You should check it out. But like in Elkhorn Slough, we need to think about the many benefits that nature can provide, both climate and otherwise, as we plan our cities and developments. So before I get into like my final slides here, I want to talk about one other thing that I think is really important. And it's something that maybe some of you have thought about in the last year or two as well. You know, we really need to be thinking in all of these actions about how we can impact equity. And there's one really unfortunate feature of climate change, which is that it tends to disproportionately impact those who have contributed the least to the problem. And in many cases, these are communities that have been historically underinvested in and underserved. Nature-based solutions are founded or based on sound science. And we have an opportunity with this science to help bring about positive change. So I want to just talk for a second about urban reforestation, or we could call it urban afforestation or tree planting. And what you're looking at on the screen, so this 4-panel map is all of Los Angeles. And what you're seeing here is 4 different things. Let me just kind of go clockwise from the top left. So the top panel is showing you something called urban heat island intensity. There's an effect in climate change where you can get these urban heat island effects. Urban areas that have lots of asphalt, blacktop and stuff, they radiate heat up, it gets really hot. And so there's this heat island effect. And you can see exactly from the red in that map where those heat island effects occur. And then next to it on the right, we have tree canopy cover in Los Angeles. And if you look on the lower left now, we've got household income. And really comparing tree canopy and household income, you'll notice that there's a pretty strong correlation on this figure between where tree canopy occurs and where household income occurs. And that means fundamentally that tree canopy is correlated with household income. So really we sort of have these like tree deserts almost in cities, and it's fundamentally like an inequity. It's systemic. It's been built into our cities. And then the map on the bottom right is showing us where there's opportunity to add trees for reforestation. We can put all of this data together, and we can make another map that looks like this one that shows us where the most suitable locations for urban reforestation are. And you know what's cool about this is we can really let the science help to guide us in where the solutions can make impact that's not only going to mitigate climate change, but that's going to benefit people and communities. So this is really cool. I think this is some really cool work. Right about at half an hour, and I've said a lot of things and talked your ears off, and I know I need to wrap up, so I'll get to the end here. This whole time I've been talking about how nature can help us mitigate and adapt to climate change, and it provides this suite of other benefits while it does so. But in all that time, I never told you, I never quantified or said how much it can mitigate climate change, and so I want to send you on your way with a number. And this was one of the trivia questions, so now you'll really get this trivia next time. There's a study that was published by folks from the Nature Conservancy in 2017. It's this paper sort of on this graphic on the left-hand side. And they looked at 20 different interventions, like the ones we've talked about today, 20 different nature-based climate solutions. And they showed that these solutions collectively can provide up to 37% of the mitigation we need if we're going to keep global warming below 2 degrees Celsius by 2030. And that is like a very significant number, right? 37% is a very significant number. So when we talk about nature-based solutions, we're not talking about tiny, minuscule mitigation contributions. There are variances, like different activities mitigate in different amounts and on different timescales, and they're not necessarily going to act tomorrow. If you plant a tree, it may take 100 years to become big, right? But the point is that collectively, when we implement these solutions now, we have real potential to make a very substantial impact in the fight against climate change. And we do that while we do all this other good stuff. So let me just wrap up. My main points, the things I'm hoping you'll take away today, are that we need nature if we're going to meet our climate goals. You know, in the beginning of this talk, I said that the IPCC, this UN body, said we need to limit global warming to 1.5 degrees Celsius to avoid the most catastrophic impacts. We're not on track of avoiding that. Right now, we've already warmed like somewhere between 1.2, 1.3 degrees Celsius. And right now we're on track to hit 1.5 degrees of warming by mid-century, maybe sooner. So there's a lot of work to be done, literally as quickly as we can if we want to avoid that warming. There's going to be climate impacts we can't avoid. And these solutions with nature can help us adapt, at least so that we can survive some of these impacts and form resilient communities that can still thrive. And then, finally, I just want to say, sometimes people ask me like, well, what is the best climate tool? And I think they think that I'm going to say, oh, nature. But actually, I think the correct answer to how we fight climate change is like this yes and approach. We need every tool in our toolkit at this point. We need to reduce transportation emissions. We need to have green energy. We need to use nature. So nature is one of the tools in the toolkit, but definitely one that we need and that we shouldn't ignore. So I'm just going to lastly share some resources in case you want to learn more. By the way, feel free to reach out to me. I have my email on the next slide. I didn't have a chance to discuss policy directly. We can talk about it in questions if folks want to, but there's a lot of work to be done in convincing decision makers that nature is not just nice to have, that it's actually something we need. You can read more on our website. I urge you, if you're interested, to contact your local and your state, your local, your federal representatives to find out how they're taking climate action and urge them to include nature in that. You can go online and calculate your carbon footprint. It's kind of fun. There's all kinds of stuff you can do. And then I couldn't help myself because sea otters are cute. If you want to see the Elkhorn Slough sea otter cam, I put the link here. So with that, I will do my best to answer questions you have. If I don't know the answer, I'll work with you to find it. And I'm going to stop talking now. So thanks.
Thank you so much. That was such an interesting talk. And we already have a couple of questions in the Q&A. So I will go ahead and read the first question. Could you talk about some of the ways that wetlands are so good at capturing carbon?
Okay, so this is a really good question. And I have to admit to you that let me just pause for a minute and explain a little bit about my role, because where I will get stuck is in trying to explain the very precise mechanics of all this. So, I am a scientist, but at the Nature Conservancy, I mostly work on policy. So I'm sort of aware of the big science behind a lot of this, but can't describe necessarily the exact details of how we store carbon. But basically, a wetland is this really interesting system. And I think actually thinking about peatlands and stuff is really interesting. You have this ecosystem that has a lot of water in it. And there's all this vegetation and maybe decaying organic matter that's under the surface of the water. And because it's under the surface of the water, there's less oxygen available than there would be on the surface. So that causes things to decay a lot more slowly than they would on the surface of the ground. And you end up with this really interesting system where there's a very gradual building up of organic matter that, because of the low presence of oxygen, is able to build up in this unique way. And there's mechanics behind all of that that make these really good at holding on to carbon. That's sort of the best I can say in this exact moment, just because I'm not an exact expert on the wetland piece in particular. So, but I can point you to a paper that works, to some resources online that can explain that a little bit better than I can. And so that's a caveat I have to add is there's a suite of these solutions. We're talking about, depending on who you talk to, anywhere between 20 to 30 of these different possible solutions. And that's a lot of different solutions and a lot of different science expertise that has gone into crafting them. And this notion of nature-based solutions is one that's pretty recent. So at the end of that talk, I quoted this 37% stat, right? And that came out of a paper published in 2017. That was only a few years ago. So this whole concept of, using ecosystems in this way is pretty new. And there's a lot of very nuanced science in each and every one of these single activities. So I would rather either coordinate offline or direct you to somewhere or someone who has the exact answer than try to guess out of here.
Yeah, thank you. I think that's a good answer. And okay, the second question from Bianca: with all of this data backing these possible solutions, how committed are policymakers in implementing these solutions?
Oh, I love this question. Okay, so again, it's my experience is mostly California, but I think it's not unlike other places too. And actually, so, California is a really interesting place to do policy. Maybe I should start by saying that every state in the U.S. is very different, right? I mean, I lived for 3 years in Pennsylvania, lived for 6 years in Wisconsin, grew up in Utah, which is a very red state. Now I'm in California. They're all different. And then we have our federal government. So there's like a lot of different systems in which we need to talk to policymakers. So that's like a first comment to just sort of think about in the back of our minds as we go through this. Now, California is thought of as, I think, a very progressive state that has thought a lot about climate change and that rightfully has a reputation of being a leader in climate. And we are. Back in the 1990s, California is one of the first states ever to set a target for its greenhouse gas emissions. They said, hey, by the year 2000, we're going to slash our emissions to be at or below 1990 levels, which we met. So California has been this leader in this space and has continued to set ambitious climate targets. But even in spite of that, in spite of all that legacy of leadership, policymakers here have not been that committed with these solutions. And I think that there are a couple reasons for it. You know, the impression that I have, and again, I'm kind of a newcomer, right? I've only been working in this space for a couple of years now. But the impression that I have are a few things. One is that I think these solutions aren't well known. I mean, they're kind of a new concept. A lot of the science is still being worked out. So for some systems, I do think, by the way, to the previous question, that wetlands are well understood. It's just me who doesn't know the answer. Forests and wetlands, there's a lot of good, robust science that talks about the carbon you can store. But then there are things like ocean strategies, like things like seagrasses and kelp. And there's a lot of robust science that's still being done to even say, hey, can we even devise solutions? So, like, some of it's new. And I think policymakers just aren't like aware necessarily of all of it. But then another issue that we tend to face a lot, and this one gets frustrating, is this notion of uncertainty or sort of permanence. It's like the Earth has this carbon cycle, and let's suppose that you improve the ability of a wetland to hold on to some carbon. But like, you can't guarantee that carbon's going to sit in that wetland forever. The land could still be disturbed and release that carbon somewhere else. And one of the pushbacks that we tend to get a lot is this notion of people being like, well, but we're not like 100% sure it's going to stay there forever, so we shouldn't do it. And that gets really frustrating because it feels like with fossil fuel solutions, like things like electrifying the grid or developing electric cars, there's risk in those solutions too. There's been risk all along the way as people have developed solar panels and solar technology and other, different technologies to reduce our reliance on fossil fuels. And it kind of feels like, for some reason, people have trouble taking that same kind of a leap of faith when it comes to nature. And I'm not sure why. So to answer that question is I'd say I don't feel like they're very committed. And I'm working right now with a coalition of different non-governmental organizations in California. There's several of us. We're all environmental organizations, and I'm like one of the newest people in this group. So I'm working with these people who have been advocating for these kinds of solutions for literally like a decade. And it seems like what's happened is again and again, the state is like, yeah, these things are important. But then when push comes to shove and when we're actually creating policy and implementing it, they kind of just get left out as nice to have. So it feels like there's a lot more to do in terms of raising awareness.
Yeah. Okay, the next question is from Tomi. What will be the cost of implementing all the proposed nature-based solutions?
Okay, I like that question a lot too. Generally speaking, nature-based solutions are pretty inexpensive. And that's because if you compare something that's like, there's like green infrastructure and what we call gray infrastructure, like engineered infrastructure. And generally speaking, green infrastructure costs less. It's for a number of reasons. It's like, you don't have to bring in like as much external stuff to do it. And, you're generally helping the biodiversity on the site a little bit more maybe than you would be. So there are a number of reasons that the costs stay low, but they do tend to stay pretty low. I actually do have a little graphic floating around somewhere on my computer. I'll see if I can find it that compares the cost of these solutions relative to other sectors like transportation. But generally speaking, these are some of the cheapest climate solutions out there. If you think about like electrifying the grid, like these solutions are cheaper than that. So they're pretty inexpensive. And I know in California, there's quite a bit of data right now. California has something called a cap and trade program. It's like a carbon market. And basically, companies that emit over a certain cap of fossil fuels every year have to participate in this program by purchasing credits. And so the money from this program goes to funding other climate and like environmental work in the state. And so we have quite a bit of robust data at this point, at least for California, at the cost of things like restoring a wetland or the cost of, restoring a forest. And you can kind of see how those compare to other things. Generally speaking, the cost is low. And another thing to add, there's another phrase, I don't know if folks have heard it, it's called the social cost of carbon. But the basic idea is like, what is the cost of continuing to emit another ton of carbon dioxide into the atmosphere? Because we know that carbon dioxide lives in the atmosphere a long time. Every ton that we emit now is going to be up there for a while. And it's going to impact people in terms of their health, their livelihood, and therefore like the economic benefits they have in their life. And so I worked on a report in 2020 where we looked at a suite of these climate solutions across California. We found where can we implement them, what kind of climate mitigation benefits do they provide? And we looked exactly this, like what does it cost and what kind of savings do we get by acting now versus not acting now? And that's what this term, the social cost of carbon, kind of captures, is the notion that acting now is invariably less expensive than waiting and acting later, because the costs to human health, the costs to our livelihood, our productivity are going to increase so substantially. So the report that we wrote found that it was something like, I can't remember exactly the number, but it was like it was many $billion saved by like the year 2050. So generally speaking, we're saving money doing this in the long run.
It's so interesting and also unfortunate that like these solutions are almost too good to be true, and yet the policymakers aren't necessarily committed yet, but we will keep working on that. Yeah. Okay, next question is from Casey. Referring to the map at the end that you showed with the areas that are best for planting with all of these other factors brought in, how does the policy side relate to this? Is there a push to actually plant in these areas from higher ups, or is it dependent on the community to enact this mitigation planting?
Well, that's a great question. There's a couple, and hi Casey, also, Casey's a longtime friend, it's exciting to see her name. This touches on a couple of things. So first of all, at least in California, again, I wish I could speak more broadly for the US, but I know my expertise is statewide, so I'll stick to what I know. In California, the state actually has a number of programs that have been established to help plant trees in urban areas. So it's something the state has thought about and has actually put funding toward. They've said, let's plant the trees. What tends to be the issue is actually not funding for planting trees, but believe it or not, maintaining them. And it turns out that like a whole bunch of times there's funding to plant it, but then there's not funding to maintain it. And that ends up being a big problem when the trees die and all this bad stuff. So one thing that we've explored is how do we help accelerate these efforts in light of that problem? And one thing we proposed to the state is to partner with utility companies. So there's this growing, I think, realization that green infrastructure is a kind of infrastructure. It may not be like a pipe or like a highway overpass, but it is still infrastructure. And when we invest in those infrastructure, we have healthier communities. So when we can bring utilities on board and have them help to spearhead the effort, that can sort of mitigate some of these maintenance issues. But in terms of like who is going to actually implement it, I think a lot of this happens on local scales. And this kind of comes back to the notion of climate adaptation. So it's funny, it's like we have climate mitigation, let's fight climate change. We have climate adaptation, let's adapt to it. The mitigation goals we see tend to be getting at the state level, the federal government, the global government, the global level. But then when it comes to climate adaptation, almost all that falls to local governments. It's going to be your local community, ultimately, that's making decisions about its land use. And in fact, that example I had where we looked at this county called Merced County and we were looking at different land use scenarios, it's the local government that decides what to do with its land use. It's the local government that does that planning. And so I think a lot of it is going to come from the community itself. And when we talk about like addressing equity especially, it's like we need to enable and empower communities to use these tools, not be like pushing them out. So anyway, I think that's a great question.
Yeah. We have so many great questions here. And I do notice that it is after 8 o'clock. So Dr. Chamberlin, are you willing and able to stay a few minutes extra? Okay. Yeah, so, no all right. So we will continue to get through these questions. And if anyone needs to go, that is fine. Thank you so much for coming. And thank you for all these wonderful questions. So you have a question from Jeremy. Have you ever experienced burnout with your advocacy efforts, and what keeps you motivated and committed to policy solutions, to some policy solutions over others?
That's a great question. So, I mean, I've only been working in the climate space now for a couple of years, I guess less than 3 years. So I technically probably haven't, I don't think I've hit like a total burnout stage. I will admit that some days, actually like getting ready for this talk, you know, in my day-to-day life, I'm not often sitting looking at like the dire data. I'm usually like in some minutia of like whatever task. And then when I sit down to put together something like this, I'm like, oh my, I look at the data and I'm terrified. And I think a lot of folks who work in the climate space, there is sort of a very high increasing level of alarm, because it is very clear that we are like hurtling toward this horrible thing. And we can all see that action is not happening fast enough. And so it's sort of like knowing, it's this like horrible knowing that like there's going to be these struggles ahead. But at the same time, I don't know. I guess I'm an optimist at heart, which never hurts. And in terms of what keeps me focused, I guess, on these solutions versus others, part of it's just personal. I grew up in a family that valued time outside. I spent a lot of my childhood on Utah public lands. My parents were like astronomy enthusiasts, and so we'd always be like in the middle of nowhere on some public land in Utah. And so I think I grew up with a very deep appreciation for nature, and understanding now that it's not just in me, that actually the science shows us how much nature can do to help people. That's just so cool. And it's a powerful tool, and it's something it's kind of like the underdog. To me, it feels like the underdog of climate solutions, that, something that's kind of been underutilized and maybe undervalued. And so those things keep me coming. And then I think aside from that, I just really like where I work. I work with a really great team of people. And so working with like these great people who are all passionate about this cause, that keeps me coming back every day.
Those are some great reasons. Okay, next question from Nicholas. For implementing your policy solutions, do you most need engagement from local, state, or federal governments? Do you more need influence with land management folks or with legislators who hold the purse strings?
That is also an excellent question. And hello to Nick. That's also someone I know. All of the above is the correct answer to that. And so let me provide a few examples. So I talked a little bit briefly about forests and about wildfire and forest management. In California, we have this huge problem where even though forests are this natural part of the landscape, we've suppressed them for so long. And now we have like this dense underbrush and these fuels that have collected, and we need to do something about it, not only because the fuels have collected, but climate change is exacerbating the problem of the fires. And so it's sort of like, what do we do? But, there was a lot of stuff that came up politically in the last couple of years where people were like, well, California needs to do more. But the fact is, we don't even own most of our forests. Most of California's forests are federally owned. It's something like at least 60% or so of California's forests are federally owned. The state owns 3% or less of all the forests. The rest is like individual corporations or tribes. So when you're talking about doing large landscape scale restoration, because you're not just going to restore 10 acres, you need to do landscape scale, ecological thinning, prescribed burning. You need to have cooperation between local government, state government, and the federal government. And so that's something that's been a challenge in the past. It's not only challenging just in terms of getting parties on board, it's challenging in terms of funding, like who's going to pay for it. And the federal government now has something called Good Neighbor Authority, and I think they have these stewardship agreements that can be used that help to kind of provide these partnerships, but I don't think they've been utilized very much yet. So, in California, one of the recommendations that the Nature Conservancy has made to California is to continue to use these Good Neighbor Authority agreements. Like, we need to be partnering with the federal government to come up with these landscape scale solutions. And then, another funny thing that comes up with governments is permitting. So I work for an environmental organization. So as you can imagine, I'm not going to be a person who's like, we shouldn't have permitting. Of course, we need to have permitting for activities. But you know, I shared that example, I think it was the Hester Marsh example, with the sea otters. That marsh, it took them like 3 years to get the permits they needed to do that restoration work. And my understanding of this, which I hope is accurate, is that they're basically being viewed the same as a developer who's going to come and like raise the whole thing into a parking lot. And so that's a problem. Like, we've been taught, there's all this talk about this being a critical decade for action on climate change. And if it takes you 3 or 4 years just to get a permit to do the restoration work that's going to help you, that's a problem. And so it's true across forests, it's true for wetlands, but in other spaces that, you know, as we have this kind of cooperation or engagement with state and federal government, we need to think about permitting barriers and not eliminating permitting, but just thinking about how we can be strategic. Like if you're doing certain kinds of work, or if you've already, you know, gone through certain hurdles at the federal level, maybe it can get expedited at the state level. There's a lot of different ways to think about that. And then just in terms, sorry, I'm like reading his question again. In terms of more influence with land management or legislatures, it kind of comes to both. In California, at least, there's been very little funding for natural resources. And so like over the last decade, the state's budget has grown and grown and grown. It's like this little curve that goes up. And yet funding for natural resources has remained consistently flat at about 3% of the total budget. It's almost nothing. Almost all the funding we get for natural resources in the state comes from bonds, like voter-approved bonds. So there just needs to be radically more funding, first of all, into all of this. But then also, like, people who are landowners, you know, there's a lot of things that maybe they're not aware of. We have things called conservation easements. You could be a landowner, and maybe you own a huge parcel of land, and you just want that land to stay as it is. Well, you can actually open up a conservation easement with the state, where basically the state kind of, it's kind of like they come in and they hold it, and you still live on it and you manage it how you will, but they're kind of like the owners of it, but you get to stay there, but it keeps that land in its state for perpetuity. So there's like lots of different ways of doing this. Anyway, that was like a very rambly answer. I'll stop now.
No, that's really, like, all of this is so interesting. Thank you for all of these answers. And I think you even talked about this next part a little bit in that answer, but we have another question from Bianca wondering if lack of awareness is the greatest deterrent for the adaptation of these climate solutions, or if there are other factors.
Yeah, I would probably say, and this is just my own 2 cents, like my employer, like my boss may have like different thoughts than me, but you know, my 2 cents is like funding is almost number one. It's like there's just not enough money for this stuff. But aside of that, I think it is lack of awareness. I think it's both. I think nature has often been viewed as like nice to have. It's this benefit we'll have on the side, and so it hasn't been prioritized in the same way as other things. And if we can realize maybe, you know, not just that nature is providing these mitigation benefits, but these other benefits, and think about it like holistically as a whole package, I think that would help. So you know, that could be a big plus. But I know like this year the California budget is just getting finished right now, and there's a lot of frustration that like there's not a lot of funding for conservation of land. And so it's sort of like, how do you do these things when there's no funding for it? So that gets really hard. I think that's a big barrier. The permitting and the funding.
Okay, and the last question that we have here is from David. How much can an individual do to help effect solutions versus government-based solutions?
That's such a good question and a hard one. It's like, and something that I think I grapple with, and I think my colleagues grapple with sometimes too. Like, first of all, of course, there are things we can all do every day to reduce our own carbon footprint. And I put the little footprint calculator in the talk, right? You could go calculate your carbon footprint, and you can do things like composting, which we just started worm composting at my house this year, which is a lot of fun. You know, you can do these little things that help. But the reality, and I don't want to discourage people from doing those things, but I also think that the reality is that the very vast amount of emissions coming out are not mostly from sort of like average people, but from very like large entities and large corporations. And so it's tough to think about like, well, what is our role in this versus how do we get the government to push on it? Certainly we can do things as individuals, but I think what we've seen from large scale corporations and just capitalism in general is that if there's no incentive or reason to change, things probably won't change. Like there's a reason that we call the current emissions trend business as usual, because business will continue as usual unless there is a reason to not continue as usual, especially if it's profitable to do so. And so, you know, I think it's going to have to be an approach that's a little bit of both, like a carrot and a stick. Like there's something to be said about making incentives for large emitters to not emit as much. But there's also something to be said about regulating. And in California, we have this cap and trade program. So we have we have like a regulated system. Like you can't emit over a certain amount without also doing something about it, kind of. And there's controversy around that. There are debates about how effective that is. There's debates that it's not working, but at least it's funding a lot of our other restoration work. So it is doing something. And without it, I'm not convinced that there would be any change whatsoever. So I don't know. That's a tough question. I think it feels good to do the individual things and often benefits us because nature just benefits us. But it is ultimately going to come down to probably there being both regulatory structures in place and maybe, you know, government-based incentives that actually really push for change.
And of course, I guess one thing that individuals can always do is vote and get into policy. So that's awesome that, you know, you have taken that path. I think that's, seems like you're doing really great work. I'm so glad that we got to hear about it today.
It's been really fun. And yes, like, please don't hesitate to reach out to your legislators. Like, the one thing I learned about working in a state government is that generally speaking, I think your representatives really do care. Like, they're very busy and they have way too many things on their plate, right? But like, generally speaking, most of them do have an open ear to their constituents because they all care about getting reelected at some level. And so, you know, it doesn't hurt to reach out and just say like, hey, you can call their office and just like, tell me what is so-and-so doing on this, you know? And you may not get the member, you'll probably get one of their staffers, but like, it's good to engage them because the more people are engaging them on this, the more that member, that representative goes, oh my gosh, this is like a thing that the people I represent care about. And, you know, that's how we sort of steer this ship, right? Or maybe one of the only tools we have to steer this ship or try to.
Well, I have learned a lot today. This is definitely an interesting thing that I want to learn more about for sure. I tend to, in my work, focus more on like the climate change and not the, you know, what we can do. So I think this is really exciting to learn about. And thank you to everyone who has come and listened to our talk. And thank you especially to Dr. Chamberlin for zooming in from California and sharing your work with us. It's been a really great event.
Thank you so much to all of you. And thanks to the organizers and all the various faces in the participant list. It's been really fun.
Yeah, thank you. Thank you all. Really appreciate it. And thank you, Sydney. It was a great talk.
Bye, everybody.